All right, so this is question 10. Three boxes are pushed together on a surface with friction. A followed by B and then C. The first box, A, has a mass of 55 kilograms, while the second block, B, has a mass of 15 kilograms, and the third box, C, has a mass of 25 kilograms. If an applied force of 250 newtons is applied on box A, the acceleration is measured at 1.2 meters per second squared forward. Calculate the coefficient of kinetic friction. So, the situation that we have are three boxes, A, B, and C, one after the other. Box A has a mass of 55 kilograms, box B has a mass of 15 kilograms, and box C has a mass of 25 kilograms. And we are applying a 250 Newton force to box A, and we also know that the acceleration is 1.2 meters per second squared forward. And so it wants us to calculate the coefficient of kinetic friction. And so given the information here, we have sort of two options facing us. One is to look at an individual block and see if we can calculate what the force of friction is on that block specifically, and then use that to calculate the coefficient. The other option is to consider everything together, right? To consider the whole system. And in principle, in this question specifically, we can go either way. However, I will be going with the combined with the system, mainly because there are less total forces acting on the object. So, if we're looking at the system, we're going to have a combined mass of 95 kilograms. We're going to have an applied force, which is the whole 250 newtons. We're going to have our force of gravity, our normal force, and our force of kinetic friction. We know that our net force is going to be equal to the sum of all these forces, right? So that's going to be the normal force plus the force of gravity plus the applied force plus the force of kinetic friction. As usual, these two are going to cancel, and so we're left with the applied force plus the force of kinetic friction. Now, our goal is to find our coefficient of kinetic friction, right? And our coefficient of kinetic friction is contained within our force of kinetic friction, right? If we write these out in their variable form, break them down a little bit more, we know that net force is equal to ma. Our applied force is just given to us as 250 newtons. And our force of kinetic friction is going to be equal to mu k mg. It's in the opposite direction of this applied force. So let's say east is positive. And so our force of kinetic friction is going to be in the negative direction. And so this is going to be minus mu k mg. Again, remember that's because our normal force in this case is equal to our gravitational force, which is equal to mg. And so now we can put our numbers in. So the mass of the system is 95 kilograms. The acceleration of the system is given to us at 1.2 meters per second squared. Our applied force is going to be in the positive direction as well, and so that's going to be 250. And then our force of kinetic friction is going to be in the negative direction, so it's going to be minus mu k times our mass, which is 95 kilograms times 9.81. And so we're going to do some algebra off to this side. 95 times 1.2 is equal to 114. I'm going to subtract this 250. And then I'm going to divide both sides by 95 and by 9.81. And that's going to be equal to our negative mu k. So we put this into our calculator, and we get that our negative mu k is going to be equal to negative 0.1459. And so that just means our mu k is going to be equal to 0.15 without any units.